Hi everybody, welcome to this Houdini demo. This is going to be kind of an interesting one where we're going to cover a lot of things pretty quickly. It's kind of a bare bones, jump into it, make something in Houdini type of tutorial, going through all the steps to get there. So without further ado, let's jump into Houdini. Okay, here we are in Houdini, just an empty file. So for this lesson, we're not going to work in the object context. We're going to work in something called the stage. So let's go to stage. And stage is a relatively new thing in Houdini. This is how USD has been implemented into Houdini. It's staged contexts along with Solaris and SOPs with Karma as well. I am definitely not an expert at this yet. It's really new. So I'm going to try and just give you the basic information that'll get you at least rendering something as you kind of develop your understanding of USD. So first thing we do in stage is we need to have something to light. So we have a node called SOP create. So we'll have that. And this will be a container. So I'm just going to jump in here real quick and just make a sphere just as a stand-in. So we know we've got something in our SOP create, and there it is. So next up is we'll create a material library. This won't really matter too much in this tutorial, but it'll build on things for later. Next thing we need is a dome light. So we can light this thing. Let's throw down a camera as well. And the last thing we need is a Karma render settings right here. And instead of using that, I think we're actually going to use the labs Karma because it's a little bit easier to understand. So we'll just use labs Karma right here. And basically what this is this is the output, the export node. Where you can render to disk and how you can set up your renders. I'm going to touch base on this. I won't dive into this totally hardcore. There's a few things we can do into Karma. One thing we need to do real quick when we put this labs down under the Karma tab, we're rendering engine. We want to switch that to XPU. And that being said, this is going to run on the GPU. So depending on your computer, you're going to get differing times. For this work. And then if we want to, we can go to Karma and we'll see that this is lit and rendered. But we don't want to do that yet. We want to start building our scene out. So to do that, we're going to go back into the SOP create and start talking about pops. Alright, so we have our sphere here. So basically what we're going to do is set up a particle simulation. And there's quite a few steps to this. We can get really advanced or kind of straightforward and simple, and I'll kind of keep it between both. So first thing we do on our sphere, let's go ahead and switch this to polygon and change the frequency up to 10. Next thing, I just always put a match size down just to get it above our grid here. So I'm going to set this justify to min. And then I'm going to raise it up above the position, we'll say 3 units, just so we're not hitting the ground. Or we will be hitting the ground, depends on what you want to do. So the next thing we do is just create a popnet. So we'll just go to POP network, and we will wire that up and make it active and jump inside. You'll see when it makes it active, you'll see some points, and that is good. It means particles are being generated. So let's jump in here and take a look. For this demonstration, we're not going to mess too much with these defaults as far as making new nodes. We are going to make some forces, but you'll see that this is very similar to any DOPS kind of setup. Here's our source. This is our object. This is where you can wire in forces, and then it goes into a solver and then to an output. Pretty straightforward. So let's go ahead. I'm going to hide the guides here, And I'm just going to hit play and we'll see what we get. So we get a bunch of points on a sphere. We can see that these points are just continually generating and not stopping. So that's the first thing we want to do, is go ahead and check our source out. So under emission type, we're just going to set this to points. We should see this, which is totally fine. Let's go ahead and do it all points, see what we get there. And that's not working either. So let's see what we got. Well, I guess we have to do a scatter. I didn't know that. The points could have been hidden. That's fine. Scatter on surface is totally fine. It doesn't really matter with this. So next thing we need to do is just take a look at the emission settings. So that's under birth. So under this impulse activation, we're going to use a small script. We're going to do $FF less than or greater than, whatever that symbol is. I think it's greater than 100. And this is going to say emit particles until frame 100 and then stop. So we'll see, we get to 100 and it's still going. So what's going on? It's because we've got our constant activation active. Let's just set that to 0 and 0. And our life expectancy, let's set that down to like, I don't know, 5. And then set the variance to like 3. And we'll see what we get after that. I just had to hide the guide geometry. That was all. For some reason, the points were just, we're hiding it. So just to recap here, we're going to use scatter onto surfaces. Birth impulse activation is $FF greater than 100. And then we're going to see, or less than 100, I'm sorry. And you'll see now we get points that are emitted and then they die and then they go away completely. And that's what we want. So impulse activation $FF greater than 100, impulse count to 500, continuous activation and birth rate will turn those both off. Life expectancy 5, life variance 3. And that's pretty much all we've got to do with our pop network, at least for now. Next thing we're going to do is play with some forces, which is always super fun. So right now we can see we don't really have any velocity. The points are just building, and they're going away. And I can tell probably we'll need a lot less than this. So let's go to, we'll go to 100. Something like that. That should be, maybe even go fewer than that, but let's see what we get. So let's get some velocity in here. So the first thing we'll typically do is just throw in a popped wind. You could use a pop force too. Wind just gives us a vector. So we'll say wind velocity. We'll just keep them at that for now. We'll put our amplitude up, and I don't have any set settings for this. I'm just going to see what we get. Swirl size, take it up, and then let's just play and see what happens. So we get this cool animation. And what I'm trying to do with this is create kind of a shape, because there's going to be little trails behind these particles. So let's try it one more time just to see. Crank the amplitude up maybe. Bring the swirl size down a bit, see what that gives us. Yeah, that's working. They're kind of flying all over the place pretty randomly, so to fix that, I'll usually use a pop drag. Throw that in there. That should give us some air resistance. Much better. And I think that's going to work for us. Cool. So the next thing I want to do with this, just to make it kind of its own thing, I'm going to throw in an axis force. This is sort of like a tornado force. So let's go ahead and pop axis force. Throw that in. You'll see it'll give us this little guide here, so I'm just going to move it up. And I'm gonna want to make this radius as big as the max radius of the particles, and maybe a little bit taller. And just to make sure it's working, I'll just throw this orbit speed weight up and then test it. Yep, there we go. So they're kind of all over the place again, so let's add a little bit of this suction speed and obviously bring this orbit speed way down. We just want a kind of a gentle vortex just to give it a little bit more motion. And that's looking pretty cool. So I think that'll do for our particles. So next up, we're going to jump into start making this actually look like something. Okay, so next up, we're going to jump out of this context and jump back into our object here. And let's go ahead and make a trail. Trail stop is really cool. Just basically puts a trail behind something. It's very, very useful. Let's go ahead. Let's just set this to something crazy like 100. And then trail increment 1, 2. All that stuff should be fine. All this stuff should be fine as well. So let's see what we get. So you can see we've got a lot more points now. So first thing I'm going to do is go back to our pop, and we're going to lower this source way down. We'll say to like 20. That might still even be too much. Yep, let's go down to 10. Yeah, I think that may work. Let's just go all the way to 2. I think our simulation's stuck here, so let's go back up to our pop net. Go to simulation, reset it. There we go. That's what I was looking for. Terrific. So now we've got lines. Let's go back in here and just add a bit more. We'll just go to 10. I think this will work. Yep, that's great. And for this access, let's go ahead and just raise this suction speed up to something like 4. Just to get kind of a cool little art directed thing here. See, it'll kind of start spinning around itself. It's pretty neat. It's pretty cool. All right, we'll go back down to bring this down a bit, bring this up. And feel free to mess around with these settings and do whatever you want. Particles are really art directable in Houdini, so there's all kinds of stuff you can do with them. All right, so now that we've got our source particles, we need to make them into something, right? So let's go back up to our trail here. And to do that, we're going to use something called the add SOP. And what add will let us do is make these into lines. There are 2 ways you can do this, and I'm not totally sure the advantage of both, so I'm just using the older way. The other way that you can do this is if we just create a null, just in case anybody's like, well, you can do it easier. In this trail, if I remember right, we can actually make this connected as polygons and then uncheck close rows. And what that should give us is lines. Yeah. It's given us lines, but they're really, really thick, which we're going to talk about next. We can set those to be a much smaller width, but this is another way you can do it without going to the add. We're going to do it with the add, so I'm going to make preserve original back here. Go to our add SOP. Then under polygons and by group, we'll get this. And then we want to do this by an attribute, like so. In the attribute, you'll see in the pop ID, because I think it shows the trail, See attribute to match, and it says ID, so we know we've got an ID attribute that we can use. So we'll go down here, and we'll just use ID. And this should give us lines, just like the other way did, which is totally fine. That's great. What this is giving us is just this really big line, which we're going to fix here in just a couple more nodes, so bear with me. Actually, you know what? Let's go ahead and just fix it now. We're going to make an attribute create. And the attribute we're going to create is going to be p-scale. And right now it automatically set it to 1, so let's go to 0.01. And now we can see how big the lines are. We can change this value, but let's just set the default value to 0.01. And now we should be getting something like this. Which is super cool. But let's go ahead and make this cooler. So the next thing I'm going to do is introduce something called the attribute wrangle. This is going to be a new node for some of you. Let's go ahead and just give us a little bit of time here. And then zoom in. Like so. You can see right now the lines, they're the same width the whole time. From beginning to end, they're the same width. And let's change that. We want them to be, to have like a fall off. So like the beginning should have no width, and then have like a little bit of width in the beginning, and then fall off to nothing. So to do this with an attribute wrangle, so we'll go to ATTR and grab an attribute wrangle. And then make sure it's running over points, and we're going to type in the following. So we know we have a p-scale attribute that we want to affect. So let's go ahead, let's go into our p-scale. So f at p-scale, and we're going to do a multiply is equals. And then what we want to drive our p-scale with is a ramp. So we're going to do a channel ramp, so ch ramp, with an open apostrophe, and then we're going to, or an open bracket. Let's go, and then I'm going to do a string, just give it a name. We'll call this curve scale. That can be anything you want. And then we want to put in the attribute that I'm going to affect, and it's going to be curve u. And then we're going to multiply all of this code, and we're going to multiply it by another channel operator. So bracket ch, and then we need to name it. We're going to call this scale, and then comma 0 as the index, and then close it off with a semicolon. So now go back over this. So we want to affect our p-scale, and what p-scale is going to equal is going to be this ramp coming from the curve u attribute, and we're going to multiply that by another value. And then once we have that entered, we're just going to hit this little box over here, and it's going to build the ramp for us. And it's also going to give us our scale value here. But there's one thing that we're missing, is this curve u. So if we go down to our attribute wrangle, and I'm just going to hit this I, if we look at our point attributes right now, we don't have a curve u in here. Oh, we do. So somehow this got generated. Let me go back. Usually the curve u gets generated by the trail. Or wait, no, by the resample. So I'm not sure where that curve u is coming from, but we're gonna change it anyway. So let's go ahead and add our resample, and this should give us our curve u. And I think that's why the curve, that line is breaking right now. It's because we don't have a curve u. I'm not sure why it says we do. So we want to resample here. And if we go ahead and look at our lines with points, let's go ahead and see what we get. So you can see they're still a little bit polygony. They're pretty stepped. So we can change that. So let's go ahead and go to subdivision curves and let's lower this a bit. So we're getting more points and we're getting nice even curves. And then I've been talking about this for the last 2 minutes. There is our curve U attribute here. So now we should be able to affect the curve attribute down here. We'll see what happens. Okay, so it's working, but now what's happening is we're not seeing it because we're just seeing the line itself. We're not actually rendering this yet. So let's go back up to Karma, or up to our render real quick. You know what? Let's go ahead and put some color on this just for the sake of it. So let's do a attribute adjust color here. And let's go ahead and set this up real quick. And I'm pretty sure we won't be able to see it, but let's just see. We will be able to see it. Great. So now we've got color. Let's go ahead and we're affecting our color attribute. That's what this node does. And then we can select the pattern type. And I'm going to remap an attribute. So we get this kind of color bar here, but we can see we're only seeing purple. So the attribute that we want to affect is age, or read is age. And now you can see we go through the full color spectrum. But if you can see, we're getting a lot of red and not much blue. That's what this source range is for. So now if I scale this, you can see that we can scale our whole timeline in here. So we're getting blues and red. Now it should start like so: purple, blue, green, yellow, and then red, all reading from the age of our string here. So lastly, we could just render these as curves in Karma, but let's go ahead and take this one step further and do a polywire, like so. And then under our wire radius, let's go ahead and use our p-scale to drive that attribute. And see what we get here. Okay, we've got our polywire here, and let's go ahead and take a look. Let's go back up to our wrangle, and let's go ahead and just name this to curve control. So we can start messing around with these settings here. So I'm going to hit play, and right now we don't have anything, and it's because this ramp value is very, very low right now. That's why we've got this scale attribute. So let's go ahead and bump the scale up, and you can see that our lines will start coming to form. So this can go way, way high. So let's just make it to a normal value. And then we zoom in here and we can see we've got topology. We've even got UVs, which polywire is really cool for that. So let's go ahead and change how our curves look. We want them to start at a higher value. So you know what, let's do this. Let's see, smooth. And if we click complement ramp, it'll invert the ramp, this little button right here. So now we can see we're starting with a larger size and then it's falling off. And we can turn our wireframe off. And you see we get a really cool animation. And the next thing we can do is go back to our stage here. Let's make sure, let's just go ahead and make an out just to make this clean. So we'll use a null. And then we'll just call this out. Go back up to our stage here. Select down to our camera. Let's go ahead and grab our camera here. Let's run the animation a little bit. take a look around. So our animation's up here. Let's go ahead and move our camera back and up and up. We'll say to about here. Let's go to our camera, lock it, and we'll do this interactively. Go to here, and we should be able to go to Karma now, and we see our lines rendered, and it's rendering almost in real time, pretty close. So we get this really beautiful kind of MoGraph type of thing. And that's it. It's pretty easy to set up. You get color this way. Your SOP create, I did a particle system in here for this demonstration, but you could create any geometry. Another thing that you can do if you don't want to work in the stage context, or if you want to render something that you've already done, instead of doing all of your work in here, you can do it in the object level. So if I say I go here and I just copy this and I go back up to our object level, I can make a new geo container and just call this curves. Paste this. So now there's our objects again, and we still have this out. So now I can go back to our stage, into our SOP create, delete all of this, right click, do an object merge, go find our output, accept, oh, that doesn't look right, go to object level, and then our out, and hit accept there, and you can see we've got the same thing. So it's just pipeline, how you want to have your pipeline. Most people will work in the OBJ context and then paste into here like I'm doing here, but I just wanted to show you a nice easy way to just, you can create things just in general in the stage context, and it's pretty easy to do. So either way works, just comes down to how many objects you've got. If you're only working on one object, it's kind of okay to just do it in the stage, but if you were working with multiple objects, you would probably want to do it this way with the object merge. And that's it. Thanks a lot for watching this video, and hope to see you again. Thank you.